an odd function, which means what?
It's the same about origin.
Yeah, symmetric about the origin. It looks the same, right side up and upside down. Does it? Besides the flaws in my drawing, that should be the same. It should be identical. This looks a little squishier than that, but come on, give me some credit. Okay? It looks the same, upside down as right side up. Sine is an odd function. The tangent. Here's a graph of the tangent. If I flip it, it looks the same. The tangent is an odd function. The same rules apply for any other odd function. Okay? Cosine's even, sine and tangent are odd. And the flip of them are. So cosine and secant are even. And the cosecant and cotangent are also equal. So, tonight we're going to be doing a lot of some transformations on the graph. So there's our general sine function with arrows pointing to what each number does specifically to that function. So you got a sine b parentheses x minus c plus d. That a, that's in front of the sine, it's multiplied in front, controls the amplitude. And an amplitude is never negative, so it's the absolute value. Okay, the amplitude is always positive. The period, from the high dot unit, how quickly the Ferris wheel was spinning around, that was controlled by that 9, the 9t, sine and cos of 9t. The period is 2 pi divided by that b value. The period is 2 pi divided by that b value. Whatever it is, that's always the case. Horizontal shift, this number here, will move the graph left or right. And then the number that's on the outside, the d term, will take the entire accordion and shift it up and down. It won't change any of the integrity of the graph. It'll just take it and literally shift it up and down. Okay? So that's the general. So you're going to be kind of playing around with this stuff tonight, graphing it. You know, what's the amplitude, what's the period, are some of the main questions on it. So here's a graph of the sine graph. And this is in radians, so this is probably day 5 of boot camp. We're going to be getting more into this. We're on day 2 right now. So from the reference triangle, the y length is 0 here. At 90 degrees, you have a y length of 1. At 180 degrees, you got a y length of 0. At 270 degrees, you have a y length of negative 1. And at 360 degrees, or 2 pi, you have a y length of 0. So that's how the graph looks like for sine. Here's its domain. It goes all the way left and right. And its range does include brackets, negative 1 to 1, and every value in between this, as far as it goes up and down. And the period is 2 pi. Now, yesterday we talked about one-to-one functions. What was a one-to-one function? What did that mean?
One input for every output.
Yes, and what does that mean? Yes. And what was the test we did to make sure that worked? Horizontal line test. So vertical line test is function. Horizontal line test is a one-to-one function, or it has an inverse function. Why in the world am I talking about inverse sine if I'm looking at this graph? What's the problem with this? As far as having an inverse. It's the worst passer of the horizontal line test ever. Worst ever. Because it keeps on going. It fail, 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 all the way down, and then if you go this way, fail, 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 fail. So how in the world can you talk about this having an inverse? Marco, you remember? Yeah. Yeah, what you have to do is you can't talk about the whole function. What you mean by restricted domain is if you cut this function here and here, you restrict the domain. You only look at a little chunk of it. You see that little chunk in the blue, in between the blue lines, Allie? Does that little chunk pass the horizontal line test? And does this little chunk have every possible y value that the sine could have? Am I missing a value? No, if you look, this goes from -1 to 1. And then it just goes from 1 back down. So it hits every value just in that little specific section. And so that's the only way your calculator can do that. The only way your calculator can give you an inverse value is if you restrict this domain. Otherwise it wouldn't know which one you want. So if you put in a ratio of 1, it'll output 90 degrees. If you're in radians, it'll give you pi/2. That's the only way the inverse sine works. Graphically, what you would do is just on this little section, flip your x and y values. The point right here is pi/2, which is 90 degrees, comma 1. On the inverse graph is 1, comma pi/2. You see it, Estella? And every point is flipped. The inputs become the outputs, and the outputs become the inputs. This is what your calculator knows as far as inverse functions. This is it. But for any value between -1 and 1 that you can give as a proportion, it'll give you an angle. It can't give you all of them, but it'll give you one. Does that make sense, you guys? That's the only way the inverse sine function works. Otherwise, it failed it. It can't have an inverse function. Your calculator wouldn't know what to do. It can't give you a billion answers. Okay? And if you look here, since you switch your inputs and outputs, the range of the sine function becomes the domain of the inverse. The x's and y's flip. Your domain becomes the range, your range becomes the domain. Everything flips in the inverse function. Okay? Here's a graph, and in boot camp, inverse graphs and all that stuff is probably the last day, day 7, probably beyond that, depending how far we go. So keep that in mind. When you're looking at this, and you need a lot more trig review. Again, what are you going to do about it? Is what I say to you. Some people got this. We did this twice last year in Math 4. Pretty strong. Might just need a little refresher. If you need some work on it, let's work on it. I'm here. No excuse. There's no excuse. If you need the work, let's do it. Here's the cosine graph. Even function, symmetric about the y-axis. In this case, in order to get all of the outputs to get the inverse function, you restrict the domain between 0 and 180 degrees, or 0 and pi. Because this little section will give you, that goes from 1 to -1 as well. So if you cut that, you can get any possible angle, or any angle that would give it to you. And so here's the graph of the inverse cosine function. Here's any input you can put in between -1 and 1. It's the only thing a cosine can equal. It's the only proportion that the cosine can equal. And it'll give you an angle. It'll give you an angle between 0 degrees and 180 degrees, or between 0 and pi. Okay? And again, you flip the domain and range. For the tangent graph, the tangent is equal to sine x over cosine x. Tangent equals sine over cosine. So graphically, whenever the sine equals 0, the tangent is going to equal 0 in all of those places. And whenever the cosine equals 0, the tangent graph is undefined.